The VX1000 can be used not only for data acquisition, but also for stimulation. Let's find out how and how easily it can be used in your CANoe test environment. Hello and welcome to the VX1000 Tech Tutorials, where you will find technical tips and guidelines for our products. My name is Jonas, and today we're going to learn some details about XTP stimulation and how the VX1000 in combination with CANoe can help you with your system tests. With me is my colleague Achim, who will guide us through all the details.
Have you ever had the need to change ECU internal variables synchronously? See how it is done with VX1000 and CANoe, as it might be the perfect solution for you to speed up your development process. You might ask, what is the use case for this? Well, there are several use cases. One is to replay recorded or artificial sensor data. This can be useful in test scenarios, for example hill tests, where your sensor can't provide real data. Another use case is fault injection testing on the real hardware. Here, false values are intentionally injected into the ECU to test how your system behaves. But how is it possible to change data synchronously with processes inside the ECU? As already mentioned, this can be done by the XTP stimulation mechanism. It always uses a duck and a stim event in combination. The duck event is required for flow control. Preparing the ECU is fairly straightforward and requires very little effort. First, you must enable stimulation in the VX1000 configuration header. Second, you place the stimulation function calls. In our demo, we have a function that provides the sensor data and a function that consumes the sensor data. Now we want to make sure that the consumer uses our stimulated sensor data instead of the real sensor data from the provider. So we place our VX1000 stimulation function call between the two functions. It contains the previously mentioned duck trigger event and the stim event. The VX1000 stimulation function has four parameters. First, the duck trigger event. This event requests new data from CANoe. Second, the stim event. This event triggers the VX1000 to write stim data to the ECU. Third, the cycle delay. This parameter defines the number of cycles between the first duck trigger and first stimulation. Fourth, the timeout. If for some unexpected reason the stim data is not available in time, this gives us the ability to delay the ECU a bit and wait for the stim data. I will use a timeout of 100 microseconds.
Achim, sorry for the interruption, but can you again please give us more details on the cycle delay parameter?
Sure. This parameter controls how data is buffered within the VX1000 hardware to ensure a stable stimulation even if your XTP master is running on a regular Windows computer. For a normal stimulation with a cycle delay value of 1, the duck trigger is sent to the XTP master. Now, the XTP master sends the stim data to the VX1000 base module. This will buffer the stim data until the next cycle, where it will be written into the ECU RAM, and our consumer will use the stimulated data from now on. Depending on your stimulation cycle time and PC performance, you can increase the cycle delay. For example, if the function is running in a 5 millisecond cycle, the parameter can be set to 10. In this case, the VX1000 hardware will buffer the stim data for 10 cycles. So even if Windows delays CANoe by 40 milliseconds to send the stim data, my stimulation will be still stable, because the buffered 10 cycles of stim data from the VX1000 hardware will be used first. Additionally, we need to call the bypass control function in the ECU code cyclically. This function activates the stimulation inside the ECU when CANoe starts the stimulation. In VXconfig, we just set the stim type to delayed mode. With my prepared CANoe project, I will continue with the next steps. As covered in previous tutorials, we need to add the events to the A2L file. In our case, I have already added the duck and stim events. that we use in the code. In addition, the duck event has been given a priority of 255 to ensure that it is handled in real time. I also added the signal I want to stimulate to our A2L file and set it to writable. Now we can finally configure the stimulation in CANoe. We check Stim Enable and configure our signal to be stimulated with the created duck and stim events. We also need to measure a signal with the duck trigger event. I will use the consumer return value to show that the stimulation was successful. Before we start, I want to give you one more hint. The value that is stimulated is always taken from your XCP system variable. So you can use different approaches like replaying an MDF file, creating a couple node, or changing the values manually. I will just change the values manually. In this demo, as shown in the video, the provider sends the value 5 before each cycle. I will now change the system variable to 10, and as soon as we start CANoe, we can see that the consumer returns the value 10. This proves that our stimulation was successful. In this video, we have explained the basic functionality of stimulation. We also showed you how to integrate the VX1000 simulation into your ECU. Finally, we gave a small demonstration in CANoe. If you would like to learn more about the VX1000 features, please contact us or check out the other videos. Thanks for watching. Already a subscriber to our channel? If not, join the Vector Tech Tutorial channel and hit the bell to be notified. Yeah! You will never miss any of our new content.